Um, Boundary systems has been around for the past 16 years, and we've been doing actually even more than that in terms of expertise. And we've been doing everything from CAD data management to product lifecycle management and simulation, as well as also product development. And this is just a small cross section of our customers that have benefited greatly from our expertise. Okay. Okay. Now, before this, let me actually pause here and show some polls, just so that way I can get a better understanding of our audience and see, where you guys are in terms of your AUC applications and your knowledge of Mathcad so far. So, two polls are going to show up on the screen, and just want you to pick whatever answer is applicable. So basically, first question is, have you used Mathcad in the past? And so, yeah, you can just pick whichever is applicable. If you've used it, sometime invariably in the past, or, you've used it many times and you're an avid fan of it, or, this is the first that you're hearing of Mathcad. Okay. Okay. Looks like we have, everyone already voted here, and I'll just share the results of this here. So basically, about 33% of people have heard are very avid fans of Mathcad, and some of you have used it once or twice in the past. But at least it looks like the majority of everyone is not entirely new to Mathcad, but you've used it some way in the past. And so I'll go ahead and hide this poll and then share a second one. Let's launch this here. So basically, and I want you to pick whatever is applicable in this particular case. What softwares do you currently use in your engineering work? So whenever it comes to engineering, either calculation or documentation, which of those, and check as many as are applicable, would you say you currently use in your work? And we'll just wait for a couple more people to vote here. Okay. Okay. So I think we have everyone already voted here. So I'll go ahead and close this and then share the poll. And basically, it looks like for the most part, the majority of our users use Word, Excel, and also AutoCAD. Some people use everyone else uses other software, just as you expect. And then there's some users of Autodesk Revit. Okay. So I'll go ahead and hide that, and we'll go ahead with the rest of the webinar. And I really do appreciate your feedback. That helps me understand how to tailor the content. And so we'll go ahead with a quick overview of Mathcad. Mathcad is started by a company called MathSoft way back in 1985. That was then eventually acquired by PTC. And for the last 20 years, Mathcad has been the leading engineering calculation platform that's existed. So Mathcad, is used by 90% of Fortune 100 companies, and you have literally hundreds of thousands of engineers across the world using Mathcad to run their engineering calculations. From a AEC perspective, so architecture, engineering, and construction, you have companies like Bechtel or even AECOM. It's not on that list currently, but PB, Parsons Brinckerhoff, Schlumberger, or even the U.S. Army Corps of Engineers. And you also have many DOTs in many states are currently all avid users of Mathcad, and so it's a tool that has proven itself well in that particular space. Okay. Now, why Mathcad in the AEC industry? And basically, it all starts with the challenges in capturing and leveraging engineering knowledge today. And so typically what you have is, you have many different tools that you're using to discover new data. And typically you have data stored in many locations. So I know some of you mentioned, you use Microsoft Word, and some others and use Excel. At the same time, you have other softwares you're using, all of those spitting out data. You also have your, CAD programs as well. And what that then means is that traceability is very, very difficult. So if you as an engineer were not sitting at your desk, any other person that looked at your computer and tried to piece together which document pieces with which other document, or which one to read first, or how everything, or how all those different sources of data relate together, it makes it very, very difficult. And so what then happens is, if that particular engineer, say for example, you retire, or you leave the company, then anyone that's hired to take your place then has to reinvent the wheel, or rebuild the same platform or the same knowledge that you've already built, because now they don't understand what you're doing. They don't understand which Excel document corresponds with which Word document, especially when you have Excel. They don't understanding an Excel formula is next to finding out gravitational lensing. It's you have, it opens up with 13 left-ended parentheses, and many times it's very, very difficult to understand all of that very quickly and easily. And so what that then means is you spend significant time bringing new resources up to speed. And once again, say you also go from one project, you finish with a particular project. When you go on to the next project, that will then require new engineering documentation. That'll require new things that you have to recreate, because now there's no standard across the different software platforms to create a template. Especially when it comes to Excel, for example, an Excel formula is almost like a one and done deal. It's fairly impossible for you to edit an Excel formula, months after the fact when you're working on another project. But with Mathcad, Mathcad basically combines all of those different repositories of data into one simple and easy to use worksheet that you can format and save and use for generations and generations of designs. Now what I'll do in the PowerPoint is I'll show a couple of the use case, a couple of features in Mathcad that are really huge and really deliver a lot of value, and then I'll go into the application and show even more. And so first off is a units management, and in Mathcad, units management is very, very huge. It's one of the hallmarks of Mathcad, and as well with any engineer, dealing with units itself is a pain. There's a reason why NASA sent a rover to Mars, and the rover burnt up, within minutes of entering Mars' atmosphere. That's because some engineer somewhere in the world did not do their units conversion correctly. And so the fact that with Mathcad, you can have it work in multiple different units, and Mathcad can intelligently understand your units and also convert between them automatically. That means that you're not making any units errors. You're not spending time wondering what's the conversion factor between feet and inches. You're not spending time thinking about or Googling how do I convert from inches to millimeters. It's as simple as having Mathcad display units in one unit system, and then asking it, hey, what's that in BTUs per hour, and it automatically converts it on the fly in less than a second, right? And so that then means that your engineering calculations are infinitely easier, and it saves you a lot of time. Now, not only does it do that, but you can also do, Mathcad is also intelligent in how it combines your calculations together. So, for example, if we define in here that we have a variable that has a units in feet and another that's a velocity, when we tell Mathcad, hey, let's add v plus y1, Mathcad says, hold on, you're trying to do something that's impossible. These units are not compatible. Now, if you try to do that in Excel, Excel will add them together. Excel will tell you, oh, adding both of those together, you get 10 plus 10 equals 20. But now you don't know that you've done something that's, mathematically impossible to add both of those together. And then that comes, that leads to a poor, engineering design later on in the field. But again, Mathcad catches this, and so it's basically automatic troubleshooting right there on the fly. Another feature of Mathcad is a templates feature, and it's really the fact that, oops, sorry about this. Okay. Another feature of Mathcad is a templates feature, and really it's the fact that you can create company standard templates and have them at the ready, so that way anyone at any time in the future can reuse those templates. And then again, you're spending less time, formatting documents and really, just capturing your engineering knowledge. And then you'll have consistent, report formatting across whatever documents you make. And you can also then improve compliance with regulations. So in cases where you have, to deliver certain regulatory documents, all of those, will have all the different, entities you need to furnish that regulatory document. And so, for example, in this case, it could be something as simple as ABC Core, and in this particular document, you have certain, unique units that you have to yourself, and you can define all of those in the Mathcad worksheet before any calculations start. So that way, then Mathcad understands what the units conversions are. Or you could have, a reports document where you could, type in there, what were the different assumptions you made, what were the different variables you had, and, what formulas and calculations did you run through, and then what's the result at the end. And all of these, again, you can either have templates on your local computer, or you could have shared templates across a network, which means then that, they're not just unique to one engineer, but, you can be used across many different engineers, right? Now, next in here is the word processing and formatting capability of Mathcad. And this is an incredibly wonderful feature, because this basically combines the industry-leading, capability of Microsoft Word when it comes to word processing, being able to type very easily, change your font, format your text, height, bold, italicize, all the simple things you need to do in order to describe what you're trying to capture is right there within within Mathcad. And so again, that means that it's improving your knowledge capture, and you're saving time creating documentations, because you're not trying to look for how do I bold or italicize this, or how do I center this and make this a header or footer. In fact, the interface or the UI of Mathcad looks exactly like Microsoft Word in terms of the tabbed ribbon interface. And so, again, it's providing a consistent, familiar environment for you to do something very simple like word processing, but again, in an industry-leading engineering calculation document. Now, next is the natural math notation, and this is again one of the hallmarks of Mathcad that many of the competitors don't even come close to doing. And so really, it's the fact that whenever you type math in Mathcad, it shows up as math. It shows up as almost like you have a pen in your hand, writing on paper. And so whenever you type formulas in Mathcad, it shows up, with the squares at the top, the subscripts, the divisions, everything just like regular math. Now, what happens if you're going to type, say a formula in an Excel spreadsheet? Well, you have to start with, 5 or 6 left-ended parentheses, and then, asterisks, and then pounds or dollar signs, and, C12 times K14, divided by E8. Who knows what that is, right? SQRT. And so what you end up having then is some long jumbled, piece of, formulae that ultimately is untraceable. If you have, 5 different engineers type the same formula in Excel, evidently, clear one of them more often than not will type the wrong thing in, Or if you have 10 different engineers try and figure out what an Excel formula means, easily it's going to take them, 5 or 10 minutes to do that. Well, in Mathcad, because of the natural math notation, it dramatically improves your document readability, which therefore improves knowledge capture. If my coworker creates something, I can very quickly understand what they made, and hence I can either add to it or use it. I don't have to, hope for the best or ditch theirs in order to recreate mine, right? And so those are just some of the highlights of Mathcad and some of the key things that it does very, very well. So now I'll go ahead and switch to a software demonstration, and we'll actually show the software itself. Okay, now so this is Mathcad, and you'll notice first off that the user interface is a very familiar, almost like a Microsoft Word kind of interface, where you have tabbed ribbons at the top, and you'll notice the document itself, it looks almost like your engineering paper, but it's very easy to use in that it can very quickly run calculations. So for example, this is a case where we have this this worksheet that's been developed, and it's a truss connector worksheet. So we basically have a truss connection joint, and we want to figure out, based on the force that that joint is going to be experiencing and the material of that joint, if we're going to be within our buckling limits or outside of our buckling limits, right? And so we can very quickly here define whatever constants we need for that joint, define our dimensions for that joint, and then go ahead and calculate the force. And in this case, we go ahead and say, and it comes out here and says, okay, this is the force on that joint, 96 kips. And now we can then go ahead with Mathcad and say, okay, well, based on our material properties that we know, and calculating based on the buckling formulas, the allowable pressure before buckling, we can calculate that. And then we can do a quick check to see, okay, do we have a good design, or are we going to get into buckling failure? And now, so this is a very easy, Mathcad worksheet that in all of, 2 pages, now we have a very clear understanding of what's going on. And now this makes this worksheet now very reusable. Now my coworker can come in here and say, well, what if, I'm designing, a new connector where instead of a material with a Young's modulus of 29,000 KSI, let's say we want to test out one with 50,000 KSI, right? You can very simply scroll down here and we see that, okay, well, the connection force has been updated. Now instead of 96 kips, now it's 111, right? We can also come here and see that in this case, the check has been updated. In this case, it's still a good design. What happens if I say, okay, just for for fun's sake, so I can actually fudge the numbers. If I double the pressure on the connection joint and I say, let's multiply that by 2. Now this updates immediately, and Mathcad says, hold on, you're going to be in buckling failure, right? So it's a very quick and easy way to create your engineering documentation in a very readable format and have many different engineers reuse that same information. Another feature in Mathcad is the programming feature, and you'll notice in this particular case here that you can have many different programming programming keywords. So if or else statements or for statements, or try different variables. And again, you don't need to know programming to create this. It's as simple as telling Mathcad, hey, if this is met, run this formula, else run this other formula. And in a very simple, easy to see interface, you can begin to understand, what program you're building and build your own logic into a Mathcad worksheet. Now, another example we'll pull up here is going to be this here, where we're trying to figure out what the lift height of a suction pump should be. So in other words, we know that we know our level of discharge, and we know where the reservoir is. We want to see how high up we can place the pump, between that distance, right? And you'll notice that in this case we have text, almost like Microsoft Word. We have screenshots for pictures. We have math, all of them coexisting in the same easy to read document, right? And so now this makes our engineering much more readable and very easy to understand. Now I'll go ahead and do something here. We'll go ahead and also show another feature, and then we'll come back to that to that sheet. What we're going to show next is a couple of things. So here we're going to show first off Mathcad's ability to work with units, and so you'll notice in this case, for example, if I say in this case, let's take let's see, I'll type it here. Let's take L and add that to Q, right? Let's take the length and add that to the gallons per minute. Mathcad says, hold on, these units are incompatible. And so it's very robust in catching whatever numerical errors I may be making. But yet I could also likewise come into Mathcad and say, hey, I know my length is in, actually I'll do it over here. I can come into Mathcad and say, let's add 1 yard plus 20 inches plus 50 meters, let's see, plus 1,000 millimeters. And you'll notice Mathcad understands everything I just did, and it pulls it out in feet, right? What if I want that result in millimeters? And Mathcad immediately converts it, right? And so you'll notice it's what if I want it in meters now? Immediately converts that. So again, it's a very easy to use worksheet where it catches and converts all of your units immediately for you on the fly. Now, I don't need to remember what the conversion between yards and inches is. Mathcad does that for me on the fly. And so again, it's very, very beautiful in the way it handles units. Now, in this particular example here, what we're going to be doing is we're also going to be solving a system of equations. And so what we have is a pipe, and we're saying we know that there's going to be 50 psi of upstream pressure on this pipe, and based on the the viscosity losses in the pipe, based on the diameter of the pipe, and the velocity and all of that, all we know is that we want the flow rate at the end to be 500 gallons per minute. The diameter and the all of those different other things, and how fast the water is flowing, I don't know. All I know is I want the flow rate to come out at 500 gallons per minute. Now in this case, we can define our constants in Mathcad, and then pull out another Mathcad feature, which is a proprietary solve block. And in here in Mathcad, what we're basically telling it is we're giving it all of our equations. We have the energy equation or flow rate equation, and we also then have the Colebrook equation, for our friction factor. And now we're telling Mathcad, hey, solve all of those things, and all I know is that my flow rate should be 500 gallons per minute. And Mathcad can intelligently solve your system of equations and come back and say, hey, based on what you've given me, this is your optimal dimension or diameter should be this value here. Now actually in this particular example, I think, so my flow rate was 1500 gallons per minute, not 500. So at 1500 gallons per minute, it comes out and says, your optimal diameter should be that. and this is going to be your flow velocity. And we can do a quick check to multiply everything and see, and yes, it comes out to 1500 gallons per minute. Now what happens if we're, this is a plumbing application and we want to reuse this particular worksheet. So, we have a new project come up, 6 months from now, and in their case, instead of 1500 gallons per minute, they want to do 5000 gallons per minute. And in their case, they're applying 100 psi of pressure, right? Instead of having an engineer rework the same calculations with a calculator, all you do now is scroll down to the bottom and Mathcad tells you your pipe diameter and your flow rate or flow velocity. So it's very, very robust and easy to use in how it generates the the results for you very quickly and easily. Now, the next thing we'll go into here is we'll flip back one level. I just showed how you can use all those different units, in Mathcad and work through those calculations. Well, what happens if you have your own units? What happens? So Mathcad has, pascals for units of pressure. It doesn't have millipascals. What happens if we work in such minute, quantities that millipascals is very helpful, and we use that a lot? Well, we can go ahead and define from Mathcad what our units should be. We can go ahead and tell Mathcad, hey, pascals divided by 1000 is millipascals. Store this as a unit, because now I'm going to be using millipascals from now on instead of pascals. And so you can also customize your own units as well, and Mathcad intelligently understands what you're trying to do and uses that in your calculations. Now, I'll switch to this here, and we'll talk about another Mathcad feature that's basically incredible. Yeah, so we'll go ahead and do this. So let's say, for example, you can build your own function. You can say, f of x is going to be 5x squared plus 2x minus 50, right? And now you can type in whatever value you want for that function. So you can say you have your whatever engineering function you have. You can then say, what if x is -1? What's my value? That comes out to -47, right? What if x is let's see here, say 10? My value comes out to 470, right? The other thing you can do is you can also pass Mathcad a matrix of variables as well. So I can say, what if I want I'll define a matrix called n, and we'll say that's going to have variables of, say, 5, 15, 100, and 2. I'll just use that. And then we can say, hey, what is f of n? And it pops that out and shows you, again, matrix form, what all those variables are, running each of those individual values through your function. Now, what we just did here is we defined one function and Mathcad ran it 4 times. If you had Excel, which many engineers sadly use as a calculation tool, Excel was not built as an engineering calculation tool. Excel was built primarily initially for accountants. If you had Excel, you would have had to copy that one formula, 4 times. What if instead of 4 data values you had 100? Well, you would have had to copy that formula 100 times before you would get an answer. And we have many cases or many examples of customers switching from Excel to Mathcad, where they reduced the number of formulas in their worksheet from 150 down to 8. Right? Again, because Mathcad is very robust and it can use functions to calculate the same data and still get you your results in a very readable format. Now, another feature in Mathcad I'll highlight here is a template feature. So, in other words, you can have your very easy to use, templates where you have your, formatting. You can have your company logos. You can have, any predefined, company standards that you want to have. So in this case, atmospheric pressure or things like that. You can have all those formatted in a very simple collapsible area. And now you can start typing out the rest of your, company documentation. Or another case would be where you can have, say for example, we'll go to a template here and we'll pick a report template. And when we open this, what we'll see is a simple report that has all the different areas already predefined and stated. So what my assumptions were and what my inputs are. I can define any functions and my analysis, and then have my results. And so now this is a consistent formatting template that you can define for your company, and it's every document that follows this report is going to look the same every time. And so again, this dramatically reduces the time you spend documenting your knowledge, and it also improves your compliance, as well. So that way, if you have a particular document you're typing out for a particular specifications, everything looks the same every time using the template functionality. Now, actually, I'll flip back one level because there was something else I forgot to mention, and then I'll come back and talk to Excel. So in this case, I was talking about the formulas in Mathcad. Well, one of the beauties of Mathcad is not only can I define my own formulas, but Mathcad comes with a built-in library of more than 500 different functions. Anything from signal processing for electricals to statistics or to design of experiments. I can run my own design of experiments. You can also have statistics formulas as well, curve and data fitting and smoothing formulas. Tons of different functions. And so now in this particular case, what actually the rest of this worksheet is a worksheet that basically describes, how many pumps do you need in order to basically guarantee, a 95% uptime. And so in this particular application, we want to make sure that there's a pump that's running at least 95% of the time. And we want to figure out how many pumps do we need to have in order to make that happen. If we know that there's a 10% probability that one pump could fail. Well, if that's the case, then we could go ahead and input our probability of failure, and then we could pull out a binomial function, which again is a predefined stored function in Mathcad that really just runs through a binomial probability density function and outputs to you the probability of a number of pumps failing. And so now in this case we can say, okay, well, with a 3-pump system the reliability is 99.7%. And so this very, very quickly now gets you an idea of, okay, if we have 3 pumps, we are going to be, pretty well within where we want to be when it comes to, making sure we have a 95% uptime on our pumping. Now I'll switch over here to showing how Mathcad also integrates with Excel. And so in this case, what we have is a worksheet that describes our basically beam deflection, and you'll notice again the very wonderful text formatting of Mathcad. But not only that, but you can also have in this case, data from Excel that we can very quickly import in. And so this table you see right here is not native to Mathcad. What Mathcad is doing is it's pulling that data in from Excel. So if I open up the Excel worksheet, you'll notice really what it's just doing is it's copying that data from these tables, from these areas in Excel, right? And it's pulling that in here. Now this connection is live. So in other words, if I say, for example, if I say, for example, instead of copying, from cell A14, what if you want to copy from cell A12? And now all of a sudden it pulls in 2 additional values, right? Now we'll go ahead and undo that here, and just go with what we initially had. And the beauty of this now is we can go ahead and basically pick and choose what we want. So say for example, we want to see what if we have this material, this beam made out of aluminum alloy, right? And we say, okay, that's going to be Young's modulus is 69. We select it from there, and we go ahead and run through the calculations, and we can go ahead and get an idea of what the maximum deflection is, right? Negative 13.12 millimeters. You can then go ahead here and say, let's read in some more cells. Let's say 12. Now, what if I want to make this beam out of pine wood? So I'll go ahead here and select pine wood. It says, okay, I'm going to select that as the Young's modulus. I'll run through the calculations, and once again, that's your maximum deflection. And you'll notice all of that it's doing on the fly, pulling the data from another Excel worksheet and pulling it in, and still able to work with it and manipulate that. Now, not only can you do that, but you also have, and I didn't show this earlier, you also have cases where you can have symbolic derivation. So you can, run differentiations, solve for x at certain values, substitute constants, and then, get results out of that. You also have plots as well, where you can generate graphs and plots of different functions. You have 2D plots. You also have, in this case, I believe there's a rainbow plot somewhere in here as well. And you also have 3-dimensional plots as well, if that's what you're into, if you have multiple variables, 2 different variables and 1 objective, right? And then finally, I'll then switch over to this other worksheet here, where I'm going to show something else here, where basically we have, in this case, we're testing out, a few different flow rates and few different, variables for a particular pump configuration. And what we have is, we're placing this information in an Excel spreadsheet, just so that way we can have clarity of presentation. So in this case, Excel is not all bad. Excel can do some things well. In this particular case, Excel can present data in tables very well. And if we want to leverage that functionality, we can do that right here. Mathcad has a very simple, output to Excel feature. If I go ahead and double click in here, Mathcad goes ahead and, in this case, I think it's already busy with that. Yeah, if I go ahead and double click in there, yeah, Mathcad is working with an Excel document behind the scenes, right? And so it's very easy and robust with how it does its work. Integrating with Excel to pull in your data or push your data to Excel, and then come out with the results. So now I'll switch back to the presentation here, and I'll go ahead and talk about a couple of the case studies that we have. Okay, now so the first in this case is Unisystems, and so this was a case where in their case, so Unisystems is an architectural and consulting firm based out of Minneapolis, Minnesota, and they were tasked with designing the University of Phoenix Stadium, and for them, part of the challenge was being able to design the stadium across cross-functional teams. And so, they have architects, they have engineers, they have structural engineers, mechanical engineers, plumbing engineers, and all those different guys need to understand what the other person is doing, and not have basically Greek or some sort of high level math that they couldn't understand. And so for them, the common platform that they were able to rally around was PTC Mathcad. In Mathcad, all those different disparate engineering disciplines could sit around together looking at the same document and then be able to understand what each other's doing. Now, one of the challenges to this particular design of the University of Phoenix Stadium as well, and which is where Unisystems excels, is that they design kinetic structures. And so the simple way to put it is that particular stadium you're looking at right there, the middle section of the stadium can open apart in fair weather and basically rest over the end zones. And so that way the stadium can either open up in fair weather or in harsh weather close up completely and become a fully closed stadium. Not only that, but the playing surface or the turf of the stadium, you'll notice in this bottom right picture over here, the playing surface of the stadium can be rolled out in order to either you can roll it in and have it be a stadium to accommodate an NFL game, or you can roll it out and have it be an arena where you can host many other functions. And so the ability to calculate all of the math to accommodate all of the different calculations you need to figure out how many winches we need, how many pumps do we need, and all of those different things to make this kinetic stadium a reality. All of that was done in Mathcad. And sort of as a overflow from here, not only have they done this, but they've also just recently completed the I want to say it's the Lucas Oil Stadium in Indianapolis. I think it's going to be the home of the Colts. Unisystems also, completed that design as well. Another example here is Hatch, and now this is an international firm. Hatch is primarily based out of South Africa, although they do work in projects all over Africa. And in their case, they wanted to have a common engineering and design platform across all of their different engineers across the different countries that they're located in. And so the end result was using PTC Mathcad, they created Hatch Tools, which is a custom company calculation tool that basically has many different worksheets that are valuable to different engineers that have different calculations in there. And really all the engineer needs to do is to swap or pick and choose whatever beam section they want, for example, and the Mathcad worksheet immediately updates and runs the calculation. And so if one engineer is looking at an I-beam of a certain dimension, he inputs that in, and Mathcad immediately populates with the resulting values of whatever they're trying to calculate. Now, in this particular case, the other incredible way they did this, which I think is actually very, very wonderful, is they didn't have a team of people sitting in a room somewhere trying to manually make or build all of these different worksheets. What Hatch did is they made their Mathcad development open source, so any engineer anywhere in the world could open an existing Mathcad worksheet and either reuse it as is or update it. If one formula is wrong, they can very quickly see that and change it. If they think, oh, this worksheet needs another formula to calculate something else, they can update that worksheet on the fly. And again, because Mathcad is easy to use, because it requires very, very little training time to get up to speed, they basically had, it was almost like a company-wide Wikipedia where any engineer anywhere in the world could open it up and make their own edits, and so that way it was then available for everyone to use. And so this then saved them lots of time because they were able to develop on the fly, and it's actually stuff that the engineers needed to use. And so that basically goes through many of the different things that Mathcad does very, very effectively, and how you can use it in the architecture, engineering, and consulting space, construction space. Now, instead of just pulling out contact information, I'll also ask at this point, are there any questions you have for me regarding Mathcad? Why to use it, what it can do? What questions would you say you have for me? Oh, now I'd also mention, if you want to ask questions, there's a questions panel in the right-hand side of your GoToMeeting pane. You may have to click on the red arrow to pull it out, but you can type any questions you have in there, and it'll pop up on my end here, and I can answer them. Okay, so I just had a couple of questions pop out here, and someone's asking, okay, well, does Mathcad integrate with AutoCAD? Which I think was one of the things that I had asked earlier was, what softwares do you use? Microsoft Excel, Word, and AutoCAD were the three that I mentioned. And in the demo so far, hopefully you've seen how Mathcad has the word processing capability of Microsoft Word. Mathcad can import from and write to Excel, and also has, infinitely more than the calculation power of Excel for an engineer. But not only that, but PTC has built integrations to other tools as well. So, for example, Mathcad has existing integrations with AutoCAD. If you use, Pro Engineer or Creo, Mathcad has an integration with that, with SolidWorks, and so Mathcad can integrate with many other CAD tools and basically push and pull information from there. So it's not just use Mathcad alone and it's isolated by itself, but Mathcad can integrate with other tools as well. And the other thing about Mathcad is that the API is open, so it has a COM-based DLL API that if you want to develop your own custom or company-based function where you're driving it with Mathcad behind the scenes, the API is open to do that as well. Okay. Okay. Another question about this is, does Mathcad come as a subscription or as an outright purchase? Let's see. I can see where that question is going. So I think in recent history, many software companies, I think Autodesk is one, and PTC is following that trend as well, have started to offer a subscription route to owning their product. So instead of paying a huge fee and owning it for life, you can pay a small yearly fee and own it for a year. And basically that becomes part of your operating expense at that point. And in this case, Mathcad does both. You can either buy it outright, pay it once, you own it for life, or you can, if you need it this year, you pay a fee and you can use Mathcad for that year. And so as a yearly subscription or an outright purchase. Now, another question that popped up, and I believe, and this was in the webinar when it was sent out. Someone asks, does Mathcad integrate with Autodesk Revit? And the answer to that is yes. And so Mathcad, as it was being built, I want to say Mathcad 15 or so, which was released, maybe about 6 or 8 years ago. Mathcad 15 has an integration with Autodesk Revit, and so you can push and pull information from and to Revit. Okay, let's see, what other questions do we have here? Okay, so another question here says, how does Mathcad compare with with MATLAB. And so I'll say from a it really depends from what perspective you're looking at it from. From an engineering calculation and documentation engine, Mathcad is superior to MATLAB, frankly. And so some of the things, for example, that Mathcad does that you won't see with MATLAB or any other tools. One of our customers that just recently purchased Mathcad did so because he came to us and said, "Hey," he said, "I currently use Word for my manuals." He says he uses Excel to store 500 or 5,000 data points that are output to him from whatever lab device he has. He says, "I use GNU plot or GNU plot to graph that data." And GNU plot is a competitor to MATLAB, and so that was why I mentioned that. And he says, "I use LaTeX to then find or figure out the best fit data values for that graph." And so he was basically using 4 or 5 different softwares, all to accomplish one goal. And all we had to do in order to make the sale was to show how in one Mathcad worksheet you could do the work of 4 different softwares. And so from an engineering documentation standpoint, Mathcad does excel beyond MATLAB in that regard. Are there any other questions? Okay, at this point, we will switch gears a little bit, and I will ask you one more question before we call it a day here. And so I'll go ahead and share just one last poll question, and I'll just go ahead and ask, based on what you've seen so far, based on on the entire gamut of things that I've shown so far, do you see value in using Mathcad in the AEC field, in your engineering calculations, or do you say, what, the jury is still out, I don't know that, this is really going to do everything I wanted to do yet. Yeah. And we'll just give a couple more seconds here for everyone to respond. And now part of the reason why we're doing this as well, we're not is also for our internal purposes as well, so that way we can get a better understanding of, our markets, and the people that are really interested in Mathcad. And, let's see, I think we almost have everyone here voted in. We'll just give it a couple more seconds. Okay, so I'll close the poll, and I'll go ahead and share the result. And basically, there's a fairly good, I think in this case, 100%, yes, in saying, what, we do see value in using Mathcad, in AEC applications, and which again, I hope is the whole goal of this webinar, is to show the application when it comes to that. And so if you have any other questions whatsoever, my contact information is on the screen right here. If you have any technical questions about Mathcad, you can email me. If you have any sales questions about how much or dollar amounts, you can send that to Sean Moreau. Or actually, let's hold on one second. I think there's another question that just popped up here that I want to make sure I respond to. Okay, so the question goes, Let me hide the poll here. Yeah, so the question goes, we have Mathcad 14 and you use VBA to move data to a Microsoft Access database. And does the latest version of Prime return to offering this API interface to VBA? And I'll say yes. The latest version of Prime with Prime 3.1, the API is now included. Now the API is open, and it's a COM-based API that you can use with you can program that with C++, Java, whatever you want to program it with. But it's basically, if I go ahead and I don't have Visual Studio tools on my computer, but if I go ahead and open this here, let me see. I'll go ahead here, and I'll just go to my Mathcad install directory. C program files. Oh yeah, Mathcad Prime 3.1. Yeah. And in here, yeah, so this particular DLL, PTC Mathcad Prime Automation.dll, is the API. And so within this here, this contains everything you need to basically open Mathcad, push and pull data or information from and to Mathcad to whatever application you have. And so if it's a case where you had an integration before with Access and with Mathcad 14, and now you want to see if you can do the same thing with Mathcad Prime 3.1, the answer to that is yes. You can build that integration here with this DLL, and you're going to be back to just how you were with Mathcad 14. And once again, and if you want to follow up on that question further, or if you have if you need more information about that, my information here is on the screen. You can send me an email or give me a call, and likewise with Sean as well. Okay, looks like that's everything. Thank you so much for watching. We really appreciate your attendance in these webinars, and we look forward to seeing you next week when we discuss solid thinking and spiral being used in automotive applications. Thank you so much, and we'll end the webinar now. Thanks.